Hello, everybody. Do a little play here. If I can find where I want my little screen. You are observing the opening that Peter did for #tip. It's a beautiful piece of graphics, vaguely steampunk vibe, and Troubles in Paradise, and so forth and so on. Welcome to Evolution Hour. This is a nice program. I'm having wonderful guests here, PC Myers and Jackson Wheat. Say hi, everybody.
Hello.
Hello.
And it's on the topic of epigenetics, which was suggested by a viewer, Paranor, who I put a field out to ask what questions would come up. And he said, ooh, epigenetics. And I went, ooh, that's really a good idea. For those of you who have not the foggiest clue what we're talking about, let's explain. Now, really, it's been a couple decades, and PZ, you can jump in and say, idiot, if I say something that's incorrect. But is it the notion that there were non-genetic methylation cues and other things that were going on that were modified and interfering and selecting these expression of genes have been something that they've been studying for quite a few decades. But in the last 10 years, 15 years or so, it's been hitting the big burner again as they've known way more about it. And what it involves is particularly the chemical modifications, these methylizations of the sections of genes. And I've got a few images that I will put up here. One I want to have there's the Scientific American article that I have put in there. My stupid screen shares. Full fart learning new tricks, and I'm very slow on this. Okay. So hopefully everybody is seeing the Scientific American article that you can find the link on. You'll see our little DNA, and you'll find all of these different complexes from the things that are pulling the molecule apart and unwinding it. And then we have these histone markers that are popping up. The histones are these little barrels that the DNA rolls around, and how those things get wound or unwound is what makes gene regulation so fascinating. And epigenetic markers are part of the signaling mechanism on this. Now, when they found out that some of these things are theoretically inheritable, at least for short term, there would be some people that were going, aha, Lamarck was right after all, inheritance of acquired characteristics. And it turns out that that's not quite so clear. One thing that popped up on all of the research that I surveyed, and I've got a link to tip 1.4 where I have a little section on epigenetics where I've been keeping track of this, and I'll put a little blurb on up about that a little bit later on. But the essence of it is that you've got this long-term natural process that's been happening that has been going on for a very long time. The Fedorov paper that I put up traces it back deep in the roots of eukaryotic cells, and it's related to how they deal with bacteriophages, particularly, and retrotransposons. And these pose a threat to the integrity of the DNA, and it turns out this epigenetic mechanism is a really nice way of slowing them down and acting as buffer zones so that they can't quite get to the DNA fast enough. And some of the stuff they've been able to trace back. Another paper I put up there, Leonova, related to, I think, some systems that go back at least to the Cretaceous. And there's just like layer on layer of defense panic attack systems that can use as bufferings on this, which brings up the point of why I put up that Scientific American paper. Because whereas intelligent design people just love trying to hijack this for design, that somehow or other information is not contained in DNA, thus spake Jonathan Wells. He's fond of that little trope, and he's kind of sometimes referring to that epigenetic issue. It's still mechanistic, it's still natural, it's still affected by all the same processes. And if they're going to try to hijack all of epigenetics for design, then they got to take the bad stuff too, because that paper in Scientific American is surveying how epigenetic markers are facilitating cocaine addiction. And so the idea that this is all sweet and cuddly for design never quite comes up in the intelligent design literature. quickie screen share here to get it out of the way. The link I put up to tip 1.4, you can get it in either a direct link at the HTML format or the PDF, and I'm going in about how Evolution News and Views calls the epigenome to be evolution's newest nightmare, and all the rest. And oh boy, it's just tragic. Anyway, somebody who really enjoys following through on all of this mess can go to thing and follow up on all the sources and be amused by all of that. So people to get a good grip on the visuals. That chart that I put up gave you some flavor of it. Screen share here for another revealing chart that I got from the I think it's from the science paper. Hopefully everyone can see that. There you can see the little gene markers, the methyl groups. You can see the little red methylization epigenetic markers, green and red as to whether it unwinds or not. So all of this fascinating mechanism that's going on. Oh, actually, this was from the Scientific American article. There we go, I think. At any rate, you can see that the complex structure that we've got in biology that epigenetics is dealing with is still subjected to all the same scientific understandings that we're getting the regular DNA stuff. And it's only acting upon what we've got in that DNA. It hasn't invalidated Darwinism. It hasn't removed natural selection from the field. Now, there I'm at a 7-minute intro with a few clumsy screen shares. Now we can get some feedback from PZ and Jackson as to whether or not that's a fair summary of the argument.
Who wants to go first? Jackson, go ahead.
I think this is more your area. I would think this is more your area. My knowledge of epigenetics is fairly little. I read a paper a little while back on I think it was Midas cichlids. There was some epigenetic work with them, if I remember correctly. I'm not positive on that, but we learned we touched a little bit on it in microbiology, talking about prions and some on retrotransposons and methylation and some things like that, but not too deeply. So
yeah, the concept has been around for a long time. I mean, Conrad Waddington, for instance, came up with this idea that it's an important concept in developmental biology that you've got to have mechanisms for modifying gene expression. They knew this even before they knew about genes. So you got to have some way to switch things off and on. And epigenetics is just an aspect of that. Another thing I'd add to RJ's ideas there is, you may have heard of all the cool stuff from Nick Lane and Bill Martin about abiogenesis and the origin of life and all that kind of thing.
I'm reading a book on that right now.
Right. And one of their points is the really expensive thing for cells is not replication, but transcription. So epigenetic modifications can be thought of as primarily a way to mark large regions of the genome to be silent so that they are not expressed. So it's not wasting energy making these things. And since we've got so much junk in our genome, it's a really good idea to have this sort of general mechanism to just suppress transcription of genes.
Yeah, even as it is, it's my understanding that in some contexts, huge swaths of DNA gets transcribed anyway, and then just kind of sits there, and then the cleanup crew comes in and gets rid of it.
Yeah, there's lots of spurious transcription going on. That's
intelligent design.
Oh, right, yeah. That's one of the reasons the ENCODE study is kind of in doubt, because they treated spurious transcription as something valid, as something significant.
Yeah.
So this is just noise in the background, so it's not that important.
They were assuming that everything that got transcribed got used, and boy, that's not true.
That's right.
Yeah, that's right. We were looking at that the other day because a creationist brought that to my attention. I was kind of peripherally aware of ENCODE, but I didn't really know a whole lot. I knew that its results been deemed controversial, but that was about it.
Yeah, they published in Nature saying that 80% of the human genome is functional, which is just total nonsense. It's
Well,
physically
and
impossible.
ID comes in. They've got to pitch this because it's part of their dogma that all the genome is functional, that there is functionally,
Right.
for all practical purposes, nothing is bad. Everything is just perfectly useless, fully functional. And so the Jonathan Wells crowd and Douglas Axe and all the rest, they've got to pitch their stuff on this. I bumped into Ann Gager and Axe both over in Seattle earlier in the year. They were giving a free lecture at a local conservative law school, which is a natural venue for science discussions. But anyway, about all the ALUs in the genome and whether or not all of them were designed, and she kind of backed off from that one.
Right. Yeah. Yeah. I think the ID crowd really likes it because there's one of the main objections that many people have to evolutionary thought is that it removes the whole idea of personal improvement, purposeful improvement from the individual. That by the way evolution works, what you do as an individual cannot improve your genetic contribution. It's kind of what you're born with. It's kind of what you die with. And epigenetics seems to be a way to get around that little philosophical problem. Is now suddenly, oh, here's a way. And if you read many of the popular books on it, which are all crap, if you read many of the popular books on it, what they're touting this way of, well, if you eat the right diet, you'll improve your genome. No, you
Like
won't.
Deepak Chopra kind of stuff.
Yeah, there's a huge amount of new agey garbage that's leapt onto the epigenetics bandwagon, just like intelligent design has.
Old Scratch has got an excellent question out there in the live chat. Are the epigenetics genes themselves? No. Markers. And my understanding of it is that in the replication process, those get carried along because the system has no way to edit them out. So that's the sense in which they become inheritable. They're kind of like parasitical hitchhikers whose functionality ends up maintaining themselves because the genes that they do continue to do the things they do.
Yeah, well, there actually are ways to change the markers. And it's kind of important that we have ways to change those markers. But it's a reflection of the hierarchical nature of development. That, for instance, when the tissues of the zygote are splitting up into the 3 germ layers, you set aside, for instance, mesoderm. It's got its own unique set of epigenetic marks, and so all the descendants of those mesodermal cells inherit those epigenetic marks and are restricted to mesodermal fates. And then as development progresses, they acquire new fates within that mesodermal category, and all the progeny from those have to follow the same fates. Just like, if you've got a liver growing in somebody, you don't want cells in that liver to suddenly decide that they're pancreas or kidney. So everything's locked in to a particular fate using these kinds of restrictive epigenetic markers.
Scratch puts up another question there. Epigenetic is what turns on and off the teeth expression in chicken embryos, right? No, I don't think so. The modern chickens don't normally have teeth. Pieces of the things that made teeth in their ancestors that are still knocking around in the genome, and with the right kinds of stimulus, I think retinoic acid pertains to like feather production and a few things like that. But I don't think it's an epigenetic marker that is used to trigger these things. And it normally doesn't occur in the animal because it doesn't really still have the whole teeth system ready to kick in.
Well, that depends on how you define epigenetic marker. I mean, there's more than just methylation that are involved in epigenetics. But yeah, the story is that chickens do have all the genes,
just like baleen whales do.
Teeth. Yeah, it's the pieces are all there, but they are actively suppressed by things like actually epigenetic markers shut down big swaths of the genome, and so they can't make teeth. And that can be overcome by things, like you mentioned, like retinoic acid. Exposure to retinoic acid will switch those genes on and induce them. One other thing I got to mention is earlier you mentioned about, is there a way to reset them? And yes, there certainly is. And that's one of the problems with interpreting epigenetics in an evolutionary context, is that in mammals and flowering plants, at least, and probably other groups as well, we reset all of our epigenetic marks in the zygote. So clean slate, where we essentially reprogram the entire genome to a common set of epigenetic marks. The only way you can get any kind of epigenetic propagation across generations is that some of those marks do escape the erasure. So you've got to have some leakage, but it's not going to be universal, and it's going to be hard to get past, and most genes aren't going to be able to avoid it. So there are still interesting phenomena going on there, but this notion of transgenerational inheritance of epigenetic marks is greatly limited by this phenomenon.
There was a survey by Panizzi and a few others. It's all in the information that I put into tip 1.4. I tried to keep the literature up on that there's effectively several different systems that kick in the slate. They are not completely accurate, and they can let stuff slip through, but there's an awful lot of cleanup crews that come in to get rid of those so that they can start at the clean slate. What's the hardest thing, and one of the reasons why developmental biology is so fascinating and exciting, is trying to get a grip on the multiple layers that are all happening at once inside of the genome, because you've got just the protein structure level is almost the boring part, because you've got those cis-regulatory systems, and then all those epigenetic markers, and then the interactions between one and the other, and then all the upper level homeobox genes that are guiding those things along in development. And it's so many non-linear systems to have to appreciate.
Yeah.
Gradually, it takes a lot of hard work to get a grip on what's going on.
That's right. Yeah. And the fact that the inheritance is so complicated means that often it's not something you can actually interpret as playing an evolutionary role. So, it may be that there are some genes where their state of imprinting is really significant for multiple generations. And in some organisms, we know that epigenetic state can persist for hundreds of generations even, so things like nematodes and so forth. But in us, no, it seems to have maybe 1 or 2 generational effect, and then it's swamped out by any other regulatory events.
Yeah, it's always a difficulty. One thing I try to advise everybody when they're going into this, especially if they're trying to interact with anti-evolutionists on it, is to avoid the press agent hype. Somebody that comes out that says such and so, let the dust settle. Yeah, you want to pay attention to the work. I always pay attention to when the commentary and criticism pieces pop up, Science, Nature, PNAS, and all of that, make a point of that. The stuff in the Science, in fact, all of the on pieces are full access right from the get-go, which is not the case for the actual paper sometimes, so it's quite hilarious. But those are the kinds of things you want to wait to see how the dust settles, because just because something hits the fan doesn't mean it's going to stick there. Dust settle first.
Right, yeah. And the other thing is that often what gets the attention are the exceptions. So yeah, we for example, in the whole junk DNA argument, where it's pretty clear that the majority of the genome is junk, what that means is that if somebody finds one little piece of it, it's got to function. Even if it's just 100 base pairs long, that gets pressed, that gets published, and then the creationists will leap on that and say, aha, this tiny fraction of the genome that has this possible role means that the whole thing is now functional.
Yeah, that's why I love bringing up ALUs, because 10% of our genome is ALUs. We got over 1 million of them in there, and they're growing constantly. And when Jonathan Wells did his junk DNA book, looked to see what he's had to say about ALUs, and he had this little teeny section on it. example of a functional ALU. Well, I'm going, excuse me, you're behind me on that one. There's a whole bunch of functional ALUs, but way more non-functional ones. And a lot of the functional ones cause diseases.
Yeah, yeah, yeah. So that, I mean, it's really hard to argue that things like lines and signs are actually significant in large part. Those are sequences that tend to get silenced. They tend to accumulate mutations and fade out over time, and they don't seem to play a role in any kind of pattern of development or behavior.
This thing, and I remember Jackson had been interacting with the creationist on it as well, and I'm sure we've all bumped into it at one time or another. This weird idea needs to be functional, that it all needs to be designed, that it all needs to be kind of perfect. And the idea that there's a huge amount of overhead, that there's a huge amount of clunkiness and kludginess to the genetic systems. And what we end up with, it will even tolerate a certain amount of actually deleterious systems, because it's the whole package that replicates, not whether or not you happen to have the sickle cell anemia allele.
Right. And, you know, the fact that there's so much junk is actually a good thing. You know, if you know the genetic load argument, that because, you know, mutations impose a cost on each generation, and we know the mutation rate, that means that a large portion of our genome cannot be functional, because otherwise our genetic load goes skyrocketing upwards. So basically all of that junk is just sitting there doing nothing, so it's free to mutate. So it doesn't impose a real significant cost.
Yeah. Most of the mutations are going to be occurring in a place where it don't give a damn.
That's right. Yeah. Yeah. So it's, you know, what matters is how many genes do you have? You know, what are their functional constraints? And all that other extraneous stuff is fortunately irrelevant to us.
Yeah, that was the one thing that really was kind of like a big, amazing shocker, although in retrospect we go, duh, was that the old paradigm was that there was going to be one gene per protein. Found out, nope, we actually have only about a third as many genes as we have proteins, and it's all multiple splicing and backwards transcription, and this huge C, which means it throws eugenics right out the window. It throws the notion that you can tinker with things like a thing to resolve particular diseases, because most of the time those things are going to affect other things as well because of multiple splicing, alternative splicing.
Well, but again, you have to be careful there, because, you know, we talked earlier about how there's a lot of spurious transcription. There's also a lot of spurious splicing going on. Yeah. So we don't know how many of these splice variants are actually functional units in the cell, and how many of them are just random garbage. I mean, I'm pretty sure that some of them are important functional units, because, you know, we find, for instance, tissue differences in the expression of certain splice variants. But those are for a subset of the proteins. And others we can suspect are just, yeah, we screw up every once in a while and it doesn't make a difference. So there's no selection against it.
It'd be nice if we had the little nanobot, all of the stuff, but we don't have that level of precision yet.
Right.
You were going to say something, Jackson.
Well, it's a good thing that we don't have the little nanobot. Otherwise, we wouldn't have the variety of biodiversity that we have today.
But we could use the nanobot to generate all kinds of new diversity.
Wrong. I'm afraid we have far too many science fiction stories to warn us about the dangers of that. Yeah. We've got a very
fiction. I'm not too worried about science fiction. Besides, whatever happens as a result of discoveries and things like gene editing, we can't even imagine what's going to happen, and we're going to be surprised no matter what it is.
Yeah, I'm hard pressed to think that there would be a case where to alleviate some suffering in the world would be prevented because somebody is worried about the nanobots taking over the world.
Be careful about science fiction, though. Portable devices that you could talk to other people on were science fiction years ago. And so,
Yeah,
Let me take a brief pause. Patreons here to remind everybody that is not made of bucks, and depends on various people to help at one page or another to help with the project. And still shows you how incredibly clunky I am that I have to do this. Stephen and John and Dyer and Eat and Yui and Mona and Hendril and Jen and Jody and Staggles and Alex Stone and Totes Real and Paul. I want to thank all of you. You can see the main website thing. All of that stuff is up there for everybody to share, all the PDFs and links and so forth and so on. That's what I'm doing it for. And you can become a patron. The video series, Evolution Hour, at the Patreon site. Or donate directly at GoFundMe.com to help the project, or to do the equivalent of buying me a cup of coffee in appreciation. All is highly welcome, and all is helping me go along one day at a time to keep going at the project. So everybody, thank you very, very much for that. We're about halfway through the show. Plug and move on to what we were discussing before. So let me check our side chat over here. Doing.
in the meantime, episode on pterosaurs. The sources for that the other day.
What about it?
Your video on pterosaurs.
There's
RJ
been
and
a
I were.
lot of new work on that. The paleontology, the new pterosaur eggs that were just found.
Yep.
And, put some material about the developmental biology. Pterosaurs are a fascinating bunch. Quirkiness, because like all Triassic critters, especially ones that are really small and have very fragile bones, they've got a terrible early fossil record, and creationists pounce on all of those things. But
That must mean they didn't evolve, RJ, clearly.
Best. I've done a spectacular amount of work on sorting out the phylogeny and the relationships. There's been so much work that's been done in the decades or so after that we're in a much better case in this new material where you can actually see the embryology of things. You can get more about the developmental biology. They involve the ones with the filter feeders, and they're actually long, thin teeth. Theoretically, since they've started to retro-engineer so much about dental bone morphological protein and sonic hedgehog and all that little happy crew, that it's only a matter of time, theoretically. The biology bunch will be working out paleogenomic reconstructions of these things and learning more about it that way. The creationists just don't seem to be aware of how the tools are advancing.
You're more optimistic than I am, but okay. Yeah.
Cockeyed optimist.
Yeah. Well, we'll see.
I think idea of retro engineering organisms, paleogenomics, all that stuff. My mind, stuff on or the Ermetazoan, just all these different
the deepest ones, and all of the paleogenomics that's been done, and it'll be this case for the next half century probably, are point issues where they can look at a subcomponent of something and take a look at it, like they did retroengineering peeling back bird beaks to realize what was going on before. What was fascinating about that issue, where they were reconstructing the archosaur dinosaur bone that produces the beak, is that although one of the genes had already been implicated, what became kind of a little mini controversy was the fact that the other gene that they were mutating wasn't one that had been previously thought relevant to this, that there was a completely different gene. So that's going to lead to even more understanding about how all of these little layer upon layer of things interact to produce stuff. And then you can go on to the point out to see whether or not there might be adaptive scenarios that would be more or less likely based upon the way that the genes interconnect.
Yeah, well, the problem with trying to reconstruct a pterosaur is that unlike those beak reconstructions, we don't have any extant species.
Yeah, exactly. Yeah.
There's no genetic material now that we could then wind backwards in the hope of finding an ancestral pattern. So that's why I'm a little bit pessimistic there, that I think entropy rules and things have decayed, and There's a limit
Yeah,
to
well,
how you play.
same thing goes in spades. Grail of homeobox genes analysis is, can you generate the Ediacara biota in variations? And that's one that some of the ones are kind of poking around at that, but I think they're going to have to dive in really closely to figure out what the very root OX system is to be able to figure that one out.
Well, again, that's got the same problem though, is that we don't have extant species of the Ediacaran biota. So, you know, we don't even know how they connect up to metazoans.
Whether they're animals at all, whether they're
Yeah.
Although I think there's been some good cases. I think Dickinsonia enough track things that it's not sessile, it moves around. Some sort of structure on it, but they're also hampered by the fact that there are no Lagerstätten deposits for those. So we've got kind of squishy, have the kind of detailed stuff that you can get at when you're looking at some of the things with the Cambrian critters.
Right. Yeah, but I still say the biggest problem is we don't have a connection to that past biota.
I mean, some of them kind of look like rugs, and we have rugs today.
Oh, there we go.
Yeah, there we go. Yes, yes. Just go to your pottery barn and look at a rug, and then away you go.
Yeah.
I've always wanted to ask a creationist though, do they think that Ediacara biota had homeobox genes or not? Do they use a naturalistic assumption in arriving at that?
Say that there's such a thing as Ediacaran biota. I think that they would say that Darwinist. But
well, since they don't.
It also bears. Go ahead, PZ.
I was just going to say, since they don't know anything about, since the creationists don't know anything about it, of course they're going to sidestep it. They don't have anything constructive.
Yeah. The intriguing thing about it is that you've got this wonderful Ediacaran biota world that went on for apparently about 50 million years, and we know little snatterings of it because of the various deposits and going. And we know that during that period, you've got a Clydina, which is this cute little ice cream cone tubular kind of thing that we know there are little burr holes in it. So apparently something is trying to get in to eat it. So we've got predation and stuff going on. And those actually survive all the way down into the early Cambrian. So there's got an overlap. What it looks like, got this whole Ediacaran biota system as a dynamic system, and then there's a mass extinction. Some of the things that were lurking around in the corners that we don't know much about, several cycles of extinction pulses before we get to the big Cambrian explosion, because you've got kind of a hole phase in the very early parts of the Cambrian where you know there's been a holdover. You've got the Clydina and you've got tiny traces of just this and that, but not a hell of a lot. It's almost like a void. Something was going on there. We just can't see it because we don't have any Lagerstätten. Then comes the fun part, the Tomotian phase. All shelly fauna. Just all over the planet, little teeny early mollusks, because they've been able to work out enough from what I understand from the biology that the kind of striation patterns and the connections inside those little itty bitty shells are very characteristic of the way mollusks are attached. So you've got these little early mollusks going all over the place. And why do you have shells? Because something's going to eat you if you don't. So there's presumably a whole predator-prey ecosystem of little teeny somethings, proto-trilobites, proto-chordates, that we don't know anything about because we have no Lagerstätten deposits. I once had various moments. My apologetic experience was with Steve Meyer when he was still up here at Whitworth in Spokane. And he had this lecture on the Cambrian. It was open to the public, and I went there, back taking notes and stuff. And I happened to ask him a question at the end on fossil preservation. And I was asking him, well, given how difficult it is to have and how trying to figure out what was going on there, I was asking him how many Tomotian Lagerstätten are there. I've hit him with a frozen fish. He hadn't a clue as to what I'd asked him, even though I'd talked with him about Lagerstätten and stuff before. And he just stares for like this longest time, and there's silence. My sister in the back of the room starts noticing that there's like nothing happening. And your point? because he didn't want to say in front of his class that he didn't know what I'd asked him. You're unknowledgeable, but good gravy, how can you not know about the terminology involved? Well, it's because he doesn't really study it all that well.
Right.
They never do, and that's why when they easy to tell. Well, I have two things to say. First is this: it's so easy to tell. They're just riffing off someone else higher up on the creation food chain because they throw word salad at you, just trying to piece through it and figure out, well, what the heck are they saying? What are they getting at? And they think, aha, I've got them now. They can't even answer.
And then if you ask just the right question, which is targeted in such a way to point out the thing they don't know, with that Timoshin Lagerstätten thing, it did come up good. Just like when I asked Huffman in that debate, creationist anesthesiologist that I had a debate with Cy Strikes Bunch a few weeks. And I finally got to ask him the question, did he source check any of the stuff he reads? And he put the classic deer in the headlight look, that absolutely patented, thought about that ever. And so a couple of the people in the live chat even called attention to it. And I'm going, yeah, okie dokie, yeah. So the methods approach is a matter of knowing what the field is and knowing the kind of the right questions to do and to avoid going off their philosophical debates and trying to figure things to where you can not only don't know, but in the process show that you know the subject better than they do and that you can actually educate the audience. So now they're interacting off of that, and now you can start talking about all these little small shelly fauna and all this kind of fun stuff. That bit. Then what you have is the small shelly fauna all but disappear, get replaced by what we can now see in more high definition, because we've got not one, not two, but three bloody Lagerstätten, which is where we get to see all those cute little arthropods. So you get this explosion of arthropod forms that otherwise are invisible. Lagerstätten to see them. Lacaris and that, I don't think there's any actually be preserved outside of a Lagerstätten context. You can confirm on that, but I don't think any of those in those Lagerstätten deposits, even though they got things with mouths and claws and all this other stuff, but they're all soft party and they don't really fossilize well. So we can only surmise of this millions and millions of years that have been going on in the late Ediacara trace fossils. You've got, and as you get closer and closer to the Cambrian boundary, you've got more and more soil disturbance, which means something's going on. And if I can ever run into a debate with a creationist on the Cambrian, I've wanted to ask them explanation question to where, oh, how do you explain the Cambrian explosion? And we'll say, well, gosh, let's talk about that. And then turn to the audience and say, how many of you have the foggiest idea what the hell we're talking about? Okay, imagine we're on a beach in the Cambrian, and there's a volcano, and there's water coming down to things. And my fellow guest, the creationist, tell us what life we're seeing. Throw it over to him to explain what he thinks was alive in the Cambrian. And whether cut it or not. The answer is really easy on the land. There's probably bacteria crawling around, but you can't see them without a microscope. Everything is underwater. It would be fascinating to find out whether or not the person, in fact, knows much about that. It's true for origins or bust questions, too. If people talk about, well, where did life come from? And to ask them on Twitter, in my Twitter jousts, what life was it? Life appeared, and what was it, and what happened next? And boy, they clam up.
Oh, I can't really deal with abiogenesis questions because they never know what they're talking about. They have never, no creationist has ever demonstrated to me what abiogenesis even is. Can't distinguish it from evolution.
Don't pay attention to much of the stuff.
And then
only knows that issue.
Just
and
throw.
We're not going to be talking about whether or not there were a duplex or triplex codons in the earliest life forms, or how PNA might relate to proto-RNA systems, and whether DNA is functioning as an RNA parasite. That's some of the current work. I've done a couple.
Or the
I've done a
Thiel-Rich
couple in
peptide
biogenesis
hypothesis.
PZ on evolution hours so far, so I'm kind of up on as much of this as possible. But then even if you get up to the upper echelon creationists, pay attention to most of the cutting edge literature either. And blind leading the blind here. It's terrible.
Mm-hmm. They're reading the creationist literature, which is just, so they're just regurgitating garbage.
Yeah, and it's what's fascinating, that the secondary addiction in the TIP project, I'm literally measuring who cites what. That 95% of some 2,000 anti-evolutionists don't cite primary sources at all. All they do is regurgitate what somebody else does. That 5%, actually secondary source addicts too. You got like 150 or so. About 45 of those are actually fact claimants. So it's a really small nested of parasitism. But what they never do is go after the substantive material. You get a lot of authority quoting. Giveaway. If somebody trots out the little prepackaged GIF that they put up on Twitter or on Facebook of the things that they've cribbed from there, and it's lacking of all sources, approach that I use is to ask where they got the material from. I'm able to track down where the material get from faster than they can tell me. So, because you can Google search text, the longer the text string is, the more likely it is that you can actually pull up on Google and find out where they're cribbing it from. Once in a while, though, I'll encounter something where I haven't a clue where they got it from, and they can't tell me either, so what the hell can we do about it?
Oh yeah, that reminds me of the aliens, Darwin's body snatchers. I'd never heard that before until a few days ago.
Yeah,
Wait,
I hadn't actually heard that one either. You brought it up for me, so I did some research on that, naturally, and it was a fascinating subject.
Basically, PZ, I think it was Carl Weiland, read from John Van Wy.
Yeah,
His name.
Carl Wieland had
Do it. Was
Go
he the
ahead,
one who
say it.
started it, or was he just another? Was he just one of the people?
well, from what I gathered from von Weihe's piece, and it was a brand new thing that he just did 2017, that somehow or other Darwinists had scavenged the remaining Tasmanian people and brought their little bones and the Aborigines to the museums and all that kind of stuff.
Yeah.
And it was based upon a guy in a popular magazine who had misread somebody's letter, and it was just a terrible piece of scholarship. The Wieland thing was particularly hilarious because the original stuff was done at the time, back in the 1990s. I had bit because I had known about Jerry Bergman, that little troll, who had been arguing that Darwinism was responsible for the death of the Tasmanians, even though the chronology is completely wrong. I mean, they were almost all dead by the time Darwin was born, so it was not really working well. But this was a totally different issue. And what's really funny is when I tracked down the sources on it, in 2009, Wieland had reposted the thing at creation.com. And then there was this 2017 edition that was just put in February, where he acknowledged that the argument was wrong, where he was now material, which he actually got secondarily. It was a blogger who was calling attention to the new work Van Weihe had done. So there again was the secondary citation stuff. You didn't even want to look at the original material. And it was
yeah, but still we have to admit that there was a lot of grave robbing and even murder carried out in the name of anthropology. But it was before Darwin, mostly before Darwin.
Of rather smug Victorian and post-Victorian racism going on.
That's right.
That you had the whole notion about the categorization of races. Partial defense, it should be pointed out that most of the smug Victorian American evolutionists were non-Darwinists. They were sort of semi-Lamarckians. And then, of course, there was Osborne, that made the goof with the Nebraska man, because they were just pissed off that all of the good human fossils were in Europe. they had Neanderthals, so the Germans had their fossils, and the Asians had their Australopithecines, and oh dear, do we, or a Homo erectus bunch, you know, do we want the Asians to have some of this? And then, of course, Piltdown, the British had a proper fossil in Piltdown, so we need something over here. We don't want America to be off of the thing. And there was an awful lot of that one-upsmanship that went on. Fortunately, the stuff, the Nebraska man sank in a hurry. There was that paleontologist who said, "Excuse me, a pig's tooth. I hate to call it to your attention, but you know." And Osborne said, "Yig," and very, very quickly backed off from it. And of course, Piltdown, it took years before the fossils got squirreled away in the British Museum, and nobody was ever. They were only looking at casts.
Well, from Osborne, even he was tentative to spread it around, to spread the.
Oh yeah, it was blown totally out of proportion by creationists. He was actually he didn't make that big of a deal out of it even at the time, and backed off quite quickly on it, quite correctly on it. But Piltdown was a far longer little material, and partly there were 2 world wars in the way. Partly because it fit British presumptions that big brains came first, which we turned out to know is wrong. And that, of course, Britain plays an important role in the evolution of human beings, as it should be, because we rule half the world, don't you know? Ha ha, pip pip. But then the other factor was, by the time you hit after World War II, fossils were coming in from Africa that Piltdown just didn't fit anymore. It really looked. And so now with the new tools that came along right after the Second World War, they said, you know, I think we need to relook at this Piltdown thing, and boop, it blew up all at once. And then of course, the parlor game for the next half century was to figure out who did it. And I think it's pretty reasonable that Dawson did it himself, that he was the primary mover in this. He was something of a hoaxer. And probably this would have blown up more in the face if he had not died. I think he died, 1917 or so. So he didn't really live very long. So the creator of the hoax was dead. And the fossils were buried in the museum, and no one was looking at them except the cast. So there were a lot of things that could have been done a lot earlier, although there were a few at the time that were very skeptical about Piltdown and offered some criticisms of it, but they kind of got shunted aside in the course of the events. Due for big frauds in the human evolution story. I mean, that's the Mount Olympus, and everything else has been about the only minor quibbles you have were some of the dating things about the Turkana tuff back about 20-30 years ago, where depending on the dating, it would determine how far back some of the Australopithecines went. And this was again flying species model. That was the obsession that they had. And by the time you get up to Johansen and all the rest now in the modern world, we recognize it's not a problem if there's more than one damned hominid going on at the same time. This is perfectly understandable. In fact, now we can see there was a thicket. And this makes much better biogeographical sense than the kind of single progression that was popular back among some back in 1960. You can jump in on that, PC, if there's anything that you find a mistaken.
No, that all sounds reasonable.
Yay, anthropology.
Oh, I love the part because it's very much a human story. Hissy fit camps of people, Solly Zuckerberg and Oxnard and all the rest, and again the single species model that they were obsessed with. The thing was whether there was going to be which was first, upright walking or a big brain, and some of them just really wanted there to be big brain first, but turns out nope.
It was clearly the aquatic ape first.
Oh, we had that was another fascinating little blip where shows how much you can do on the basis of limited information before they even knew DNA. And
the chimp pig hybrid was first.
Holy moly, that fellow, that one, it still pops up.
There's only one guy who believes that. Come on. Yeah,
it's a minor niche, and that's why it's fun to see do stuff. It's like when you find a creationist that brings up the lunar dust myth. Why are you behind the curve? That they clearly haven't even bothered to read recent stuff, which I think most creationists don't. Jackson kind of caught more of my methods bug Travis case, because I was able to save him a bit of time when he was doing some jousts with some creationists, where he was having some trouble finding an old paper, and I'm going, oh, that one, I know about that.
Dabbing rather than a joust. Repeatedly.
Yeah, I think it's so delightful, and of course I've been following PZ on Pharyngula and the panda's thumb and that for years and years, and also with Jackson, is that the more people that get together with technical expertise, the easier it is to connect up stuff in areas of expertise you didn't know were out there. So I'm honored that Jackson throws his various scripts at me to vet through, and every time I find examples of science material I wasn't aware of, and then I do follow-up work to check it out and look it up, and it beefs up my own material, and I go, ooh, did you know about this paper? And I'll throw it back at Jackson and all the rest. And so it's such an exhilarating enterprise because we've got so much available.
Yeah, it's having people to groups. I can do an okay job, but I also like to have second opinions, and of course you can pull research that I can put in there too. I'm only one person. There's only so much myself. But although interestingly,
I found that. Oh, continue.
Oh,
go ahead. Yeah, I'm jumping in. My bad.
In an upcoming video, I'll be talking about plant Sarracenia, yeah, and yeah, Savannah and I got to hear that talk at the Museum of Zoology, which was really cool.
Yeah,
interesting.
Yeah, what he's referring to is wonderful work. The biogeographical relationships of particular plants and their specialized hosts and parasites, and how they can jump as a group or not. You can delve into the dynamics of these things and look at the fine point details, and that was just wonderful stuff. That the original paper that you mentioned I didn't have in there, but then the other follow-up paper that I was able to find. So between the two of us, then we step ahead, and now both of us know more than we did before.
I think it's just so cool to see it synchronously. Basically, a flesh fly and another fly odds that live with the, and when it dispersed across the Mississippi River at the same time two of these other arthropods did. It's very interesting stuff, which I'll talk more about like 2 videos.
Yeah, absolutely nobody can have anything approaching a life and stay up on all the technical literature. I've got over 1,700 technical journals listed in my bibliography. And that's just nobody. No human can pay attention to all of that stuff. So I basically will hit PNAS and Science and Nature weekly as kind of the top edge. But then I depend on my network. People that I follow on the tweet storm. Whenever I find any of the technical scientists who are on Twitter, I'll follow them. Heads up. They're following the work for me, and some of it is relevant to tip and some of it isn't. But the thing is that now that's giving me an avenue by like spider things where they can vibrate for me, and I go, ooh, that's something that I can bring into the mix, and that accelerates the process altogether. Much of it's available open access. That's the wonderful thing. I've got so many nice little black boxes now on my source listings that are ones where I've got full text, either PDFs or full printouts, and that was just not possible 15 years ago.
Oh yeah, just today, / on testing last universal common ancestor.
Thornton's paper.
You've heard about that stuff, PC?
Oh yeah, yeah.
Creationist, the intelligent designers dumping on it, oh, this is just more of the Darwinian assumption and blah, blah, blah. But then if you ask them here, what would you accept as evidence? Change your mind. You're going to get the deer in the headlight really fast on that one, because literally, creationist ever thinks about that. I don't have to guess. Going all the way back to St. George Mivart in the 19th century. If you've ever read his old book, which is also available free online, kind of song and dance routines that William Jennings Bryan was going through in the 1920s and 30s anti-evolutionists, and it's the same stuff Steve Meyer and the Discovery Institute go through today. It's that they've got this tropes that they hang their argument on, but they don't actually turn it into, well, I would accept this. For example, was Jonathan Wells.
There's another strategy though that's pretty
jump
common.
in.
Look at what Ken Ham does. He just says, "No, I will not accept anything that goes against
He's
my
honest
interpretation."
about it.
Yeah,
I can't prove it to you, but no one will ever tell me that the Bible is not the Word of God.
right. Yeah,
I would have loved to have been at that Nye debate, because there was a thing where poor Nye, of course, was trying to come up to speed in like 2 weeks. And they had to give him a crash course in creationism because he's never really followed it much. And Josh Rosenau and others did a perfectly fine job, but there's only so much you can do in a hurry. But when I saw the presentation, one of the slides they put up, that Ken Ham put up, had to do with baraminology and the created kinds. And there was a chart that one of the ones is a triceratops, and there was a couple other animals that were up there. And all these little squiggly lines are coming up, and supposedly some of this is being filtered through the flood or not, and there was no chronology, and there were no labels, and it was very, very vague in general. And it's also at their Creation Museum. And that would have been a perfect opportunity, because there would be evidence that Ken Ham was putting up. Him, oh, Ken, I'd like to know, are Psittacosaurids a monobaramin in that baramin or not? And just see him go, whoa. Oh, don't you read your own stuff? Don't you pay attention to your own argument? Well, gee, why are you here?
No, they do not, because most of them won't. If they think that Australopithecines are not an conspiracy as Paradise Lost indicate, if they even accept that Australopithecines were real at all, plain monkeys.
Yeah,
and then you look at
Lucy was just a chimpanzee. I get that all the time on there, and I go, oh,
at,
says who?
That Wood, is it Todd Wood? The paper where
Todd Wood, yeah, the one where he actually managed to put.
Yeah,
You may not be aware of this, PZ, but Todd Wood, who is one of those honest creationists who acknowledges that evolution is not a theory in crisis, and he's also one of the baraminologists, and he had done a paper where, prepare for your mammal jaw to drop, announced that, according to his baraminology analysis, Australopithecus sediba holobaramin. How the hell does he manage that little trick? This is just astonishing, and I know exactly how they do this trick, because of the baraminology thing that I looked at on the reptile-mammal transition was exactly the same problem that all of them do. They flush data down the drain first. So they're parsing of the cladistic numbers that they're feeding into their little formulas, and inevitably they're going to get weird connections that really shouldn't be there, because they're looking at too small of a data stream, or missing connections they should be seeing because they're missing too much of the data stream. And so that weirdness unusually in there, that he can't put Australopithecines in the human baramin. I mean, I'm afraid that makes Eden a really unusual place.
Well, but the thing is that when you're a creationist, you don't have to care about the consilience. You don't have to care about the convergence of the evidence. That you just pick and choose. And if you find one little piece that supports your opinion, you just present that. You're done. Poof.
I do feel sorry for poor Wood, though.
Their article on the average dinosaur size, because they got to fit it onto.
Yeah.
And so to do that, they start out by saying, okay, for this analysis, birds are dinosaurs, so no birds go in there. Bird-like dinosaurs, like Microraptor, which is clearly dinosaur, but they wouldn't even include Microraptor in their analysis because it was too bird-like.
Yeah, you don't want to, if you flush data down the drain. And the other thing, of course, Leitner, and I mentioned her in Slam Dunk too, she is the one who has tried to find out how many bird kinds there are. And I think she comes up with like, it's either 186 or 196, something like that, bird kinds. And one of the kinds is the finch kind. 100 species of finch are all part of a created kind, which means functionally she is accepting those finches have evolved, and all of the ones in the South American grass quits and all the rest are actually physically related. Deal with any fossil data, so that
Are you talking about
amidst all
Purdom?
that. Susan Leitner.
Oh, okay. I was.
Yeah. Oh no, Purdom
Purdom.
hasn't really done any really serious systematic stuff. Well, she's done some air quotes biology, and she has actually been published in regular science journals. She's one of those little fact claimants. Not
Yeah.
that's been published, not very notably, but still. There's a small bunch of those. I think 69. I've got a number so far. 1,000 scientists that I cover in my hashtag Get Data set. So you can see there's a great surge who have been published in mainstream literature.
I've got a clip of video that she was in an interview for Answers in Genesis where she says there is a bird kind, store kind.
Yeah, you get that a lot. Don't read themselves.
Of them is one kind.
Yeah, creationists don't read most creationists. I don't. When Ken Ham has in his museum the wonderful baraminologists written on the little chart, I don't think for a moment he's ever read any of it. For one thing, because he was still trotting out the idea that the horse sequence is a problem. After their own creationist, Todd Wood and company, had worked out that all of the horses in the horse sequence are part of a monobaramin and therefore naturally evolved subset of a supposed horse baramin. And so the very thing that he was insisting couldn't be true, their own creationists had done that, but he doesn't read any of that stuff.
Why should he? He's got the Bible. Just read that.
Well, Ken Ham is a secondary redactor. That's one of the dynamics about creationism versus intelligent design that's so striking, is that most of the people who are the point people in creationism are not their fact claimants. The Georgia Purdoms and the other bunch down in the fact claimant floor usually do too much apologetics. They're not the public face. So Ken Ham and Kent Hovind and Ray Comfort, they are secondary parasites. Move over to intelligent design. Purposes, all the design movement publishes at Evolution News. Reader, the writer list there, that is the design movement, and there's only like a dozen of them, and if you gathered them together in a room and a bomb went off, you would literally have vaporized the intelligent design movement.
Don't give me ideas.
Oh no, we don't want to do that. No. It's much better for them to have to do source checking.
Dang.
Yeah.
I want to see Jonathan Wells try to. Oh, I asked Jonathan Wells, by the way, when he was also at that coffee clutch over in Seattle, where I bumped into X and Gager, and I actually came up and asked him a question. It was terribly hilarious because after he had finished his spiel, which was just the usual boilerplate about, where he was also arguing that there's no genetics to nearsightedness. He was doing a whole bunch of amazing claims that had no bearing in fact. But anyway, nobody wanted to ask him a question. There was just crickets. And I got up and walked up to the microphone and I said, oh, come now, doesn't somebody have a question to ask him? Because I did. Whether or not he played any role, what part he played in writing the reptile-mammal transition sequence of Design of Life with Bill Dembski. I knew that it was a complete crock, and I wanted to find out which one was responsible for the crock. And it turned out he had played no role at all in it. It was all Dembski's baby, which kind of surprised me because Dembski has no interest in paleontology, and Jonathan Wells obviously has no expertise in it. But I thought at least he tried because he'd written Icons of Evolution and all the rest. So that was a little data blip on there that I would be including in a revised edition if I could get that off the ground. Well, we are past the hour mark. Let's do a little summary because we did on that. The upshot is that epigenetics is a fascinating sidebar to modern biology, which is a cutting-edge field looking at how all the cute little markers and methylation and a whole bunch of other factors that are occurring on top of and external to the DNA that are helping in the whole DNA process of replicating and what gets transcribed and what gets used and not. And that although anti-evolutionists have tried to hijack this for intelligent design, they have failed miserably to do so. And the actual work continues to be done by the evolutionary community. And the not paying attention to it part is what the anti-evolutionists do. Would that be a fair summary of the...
Sure, yeah.
I'd say so.
Oh,
That
okay,
epigenetics-
well, thank you.
I was going to say, are we stopping? Should I just stop?
Not yet, not yet.
Okay.
By all means, I won't stop when you're going to say something.
Okay, I was just going to say that epigenetics is really important in developmental biology, and it's always going to have a place there, and it's actually kind of central to the whole program of developmental biology because it's basically gene regulation. But at least in most species, it is not going to play a significant role in evolution. And that the main reason people wanted to play a role in evolution is because it sounds like a way for people to manipulate their individual genomics. And no, you can't do that either. So there's a lot of wishful thinking driving the popular approach to epigenetics.
Yeah, Lamarck is not resurrected in epigenetics.
Nope.
Sorry. Get inheritance of acquired characteristics, and those of you who think it does, oh boy, are you going to be in trouble. Well, I think this was an entertaining and useful show, and I very much enjoyed having the guests. Hope you will be guests with us again sometime, PZ. That was really wonderful, and it's always wonderful to have Jackson. I feel intimidated when I do read-throughs of his video scripts because he has all of these technical taxa names in there that I know I am butchering when I'm doing my read-through on there and realize that his tongue than mine does. But anyway, thank you all very much for joining the show, and hope the viewers had a wonderful thing. Thank you, Paranor001, for suggesting the topic to begin with. And we will have another Evolution Hour next week at the same time. Thank you very much, and stop in the broadcast.